Hello everyone. In our last video, we learned how to divide a polynomial by a monomial, which is just another polynomial, but it has only one term. And the first polynomial, the dividend, had contained more than one term. In this video, we're going to learn how to handle the situation when both the dividend and the divisor have more than one term. If you recall from our previous video, dividing a polynomial by a monomial does not require the utilization of long division. However, when it comes to dividing a polynomial with more than one term by another polynomial which has more than one term, we must use long division, and the utilization is mandatory. If we recall just a simple long division problem with numbers, that will go a long way in helping us figure out how to do this for polynomials as well. So if you recall, if we just want to do a simple problem like 136 divided by 7, right? The first thing we do is we look to see if 7 goes into 1. It doesn't, so then we check 13, and of course we know 13 divided by 7 does work. It gives us 1, so we write the 1 here, we multiply, we write the answer here, then we subtract. We get a 6, then we bring the next number down and we see if 7 goes into that, and it does 9 times. We multiply, we write the answer here, we subtract, right? So now we can no longer keep going because this is less than that, so 7 doesn't go into 3. So now what we're going to do is write this as a equation of this form. So that means what we have just discovered is that there are 19 sevens within 136, and if we take those out, we're still going to have 3 left over. So the way we write that is we say 136 equals 19 times 7 plus 3. Now, just to get some terminology out of the way, the number that you're dividing is called the dividend. The number you're dividing by is called the divisor. The resulting answer is called the quotient. And if after taking out all those, you have something left over, that becomes the remainder. Now, if we look at the procedure, basically what's involved is dividing, then multiplying, then subtracting, and then if possible repeating until you can't repeat anymore because it won't work. So if we look at this in more general terms, we use the capital letter, the capital D for the dividend. We use lowercase d to denote the divisor. We use Q for the quotient, and we use capital R for the remainder. So if we write an equation similar to this, we end up with capital D equals QD plus R. This is an important equation, and it's called the division formula. It's basically the formula that describes what's happening in this operation. Now, we'll use the exact same procedure to divide polynomials when the divisor contains more than one term. But before we do that, in order for our process to work out smoothly, there are always two things we want to make sure. We want to make sure that both the dividend and the divisor are in descending order. That just means, for example, you want to have, let's say, x cubed plus 3x squared minus 5x plus 1. That's what we mean by descending order. Highest power first, then the next one, then the next one, all the way to the lowest. The other thing, and we want to make sure both the dividend and the divisor are in that format. We also want to make sure that there are no missing powers. If there are, we're going to use what's called a filler. For example, imagine instead of that, I just had x cubed minus 5x plus 1. This is what we mean by a missing power. So notice we've jumped from a cubic term, a third degree term, to a first degree term. So we're missing the second degree term. So we would go ahead and write a 0x squared in the place where the x squared term would have been. And notice we're not changing the problem because 0x squared is just 0, and adding these 0 doesn't change anything. So, but however, it's a format that's going to be helpful to us, as you will find out soon. So this is what we're referring to as the filler or the placeholder. Either one works. Let's go ahead and take a look at this problem now. So remember, there are two checks we always want to do: descending order check and the missing powers check. So notice both of the dividend and the divisor are in descending order indeed. See, second degree term, first degree term, 0 degree term, first degree term, 0 degree term. Because remember, when you have a constant like 3, you can write it as 3x to the 0, or 1, you can write it as 1x to the 0. That's why we say 3 and 1 are 0 degree terms. All right, so now notice that both checks are passed. We can go ahead and proceed. So we go ahead and write the dividend and write our division sign, long division sign, and we will go ahead and write the divisor to the left of that sign. All right, the procedure is going to be very much like before. We're going to divide, then we're going to multiply, then we're going to subtract, and if necessary, we're going to repeat. However, when we divide, it's actually much easier than in the case of numbers. We're always going to divide the highest degree term here by the highest degree term here. So it's a much more systematic approach compared to before in some ways, and much more routine. All right, so we divide x squared by x. I'm going to show you the work on the side here. This is not, you know, something that's part of the problem. It's just that we're showing the work on the left. So we divide x squared by x, we get x. So we're going to write this here. It's nice to write it above the x term here. And then we're going to multiply. Remember, we multiply this by the part of the quotient by the divisor. And here, of course, since the divisor has more than one term, there's going to be distribution involved. So let me show you. You're going to divide x by x plus 1, and you're going to get x squared plus x. So we're going to write it down here just as we did with the case of regular numbers or constants. All right, so now we're going to subtract. And of course, x squared minus x squared should cancel out by design. This should always happen. If this doesn't happen, this wasn't found correctly. So we go ahead and cancel those. And 4x minus, of course, it's 0x squared, which is just 0, which we don't need to write down, because 0 plus or minus anything else is just going to be whatever the other thing is. So 4x minus x will give us 3x. I guess I should say 0 plus, not plus or minus. That's what we meant. All right, so we get 3x because 0 plus 3 is 3, but 0 minus 3 is not just 3. It's negative 3. So what I meant was, whatever this part is, it doesn't change. If it's positive 3, it remains positive 3. If it's negative 3, it remains negative 3. So I don't want you to get confused with that. All right, so 4x minus x is 3x. We bring down the 3. Now, we notice the degree here is 1, the degree here is 1. We can keep going. This is, you can still divide 3x by x, right? So we go ahead and proceed. So we repeat now. So we divide the first term here, which is 3x, by the first term here, which is what we did before. Remember, we divided the first term by the first term. Now we're repeating the process. We're going to divide the first term by the first term. and we get 3. So we go ahead and write that up here. So we get, it's positive 3, so you have to make sure you write the sign. You don't just write 3 because it's going to look like multiplication. You don't want to make that mistake, so you have to put the sign. If it's a positive 3, you put plus 3. So now we're going to multiply again. So that means we're going to multiply 3 by x plus 1. And we end up with 3x plus 3. So we write the 3x plus 3 down here now. And we subtract. We notice these cancel out, so do these. That means we're left with 0. So that means the remainder is 0. Notice, for example, if you divide 6 by 3, you get 2 times, and you end up with a remainder of 0. So what does the remainder of 0 mean? Just like here, it meant 3 goes into 6 perfectly, exactly 2 times, leaving nothing behind. So that's exactly what this means. This means x plus 1 goes into x squared plus 4x plus 3, exactly x plus 3 times, and it will leave nothing behind. So basically, we have just shown that x squared plus 4x plus 3 divided by x plus 1 equals x plus 3. So that means, just as in the case of 6 over 3 equals 2, means 3 times 2 equals 6, in exactly the same way, x plus 1 times x plus 3 should give us that. And of course, we can check that using the division formula as well. Remember, d equals q d plus r. And here, since r is 0, we should just get d equals q d. So let's check that. Let's go ahead and multiply q. Apologies, this whiteboard is not as cooperative as the one I have in the classroom. All right, so we're going to multiply. Remember, this is what we call q, and this is what we call d, or the divisor, to see if we get d. So basically, we're going to multiply x plus 3 by x plus 1. This is considered the check here. And we get x squared. Remember, we can use FOIL. So the first times the first, then the outer, which is x, then the inner product, which is 3x, and then the last times last, which is 3. So notice we get x squared plus 4x plus 3, which is exactly as it should be. All right, so again, that means when the remainder is 0, that means the divisor goes into the dividend exactly as many times as the quotient. Okay? All right, here's another problem. We're going to do the descending order check and then the missing powers check. So is this in descending order? You can clearly see that it's not. So we need to fix this. We will in a second. And how about this one? Is this one in descending order? No, we need to fix. So we need to fix both d and d, the dividend and the divisor. How about missing powers? Is this does this polynomial contain any missing powers? No, we're going from cube to squared to first degree to 0, no missing powers. Nor is this one. This is a first degree term, that's a 0 degree term. So this one we're fine. So we're just going to put both in descending order and proceed. So the first one becomes y cubed minus 2y squared minus 5y plus 9. That's our dividend right here in descending order. Y cubed minus 2y squared minus 5y plus 9. Now we go ahead and write the division sign, and we put our divisor also in descending order. So we write it as y plus 2. You should know how to do this after watching the previous one. I would definitely encourage you to pause the video, go do it on your own, and come back, see if our answers agree. Alright, so now we'll proceed as before. We're going to divide the highest degree term here by the highest degree term here. That means y cubed divided by y. We'll show that on the side. We know that's y squared. So we go ahead and write the y squared here. Now we need to multiply. So that means we're going to multiply y squared by y plus 2, which will give us y cubed plus 2y squared. So we go ahead and write that here. So we get y cubed plus 2y squared. Now we're going to subtract. Remember, it's always the top term minus the bottom term. So y cubed minus y cubed, not surprisingly, cancels out. Now here's where you have to be careful. This is where most people who don't get these correctly make their mistakes in this subtraction. So remember, you can always show it on the side. You're dividing. Let's just go ahead and be consistent here. If I'm going to show the work, I'll put it in red. Negative 2y squared minus just 2y squared. We don't need to write the plus, right? So that's going to give us what? Negative 4y squared. So down here, a lot of people who make a mistake, they cancel these. You're not adding, you're subtracting. Top minus bottom. It's always like that. So negative 4y squared, we can go ahead and bring down the other terms. Minus 5y plus 9. Now, of course, we're going to repeat. So negative 4y squared divided by y. That gives us negative 4y. So we're going to write this negative 4y here. And now we're going to distribute. We're going to multiply this by the divisor. So that gives us negative 4y squared minus 8y. So we'll write that here. And now we'll go ahead and subtract. Remember, top number or top expression minus the bottom expression. So negative 4y squared minus negative 4y squared. So that turns into plus, right? So they cancel out, as they always should. Negative 5y minus negative 8y. So let me show you that here. We have negative 5y minus negative 8y. Notice those turn into a plus. So actually, you actually end up with negative 5y plus 8y, which is positive 3y. So we put 3y here. Bring down the 9. We can go one more time. Divide 3y by y. and of course that gives us 3, right? So we're going to write the 3 up here. Don't forget, you have to put a sign, so put plus 3 if it's positive. So the last thing that we need to do is we need to multiply that 3 by the y plus 2. So let me just keep going here. So we multiply 3 by y plus 2. I think I'm gonna not do this 2-color business next time. So 3 times y plus 2, so we get 3y plus 6. So we're going to go ahead and write that here, of course, under this. And we subtract. The 3 y's cancel out. 9 minus 6 is 3. Now, the degree of this term here is 0, and the degree here is 1. That's exactly when you stop. When the degree here is strictly less than the degree of the divisor. Even if it's equal, like it was in this case, notice the degree here is 1, because the highest degree term has a power of 1. And the degree here is 1 too. As long as even they're equal, you keep going. But once you get to a step where the degree down here is strictly less than the degree here, meaning here the degree is 0, here the degree is 1, that's when you stop, and that will be your remainder. So, for example, if we look at a real simple example, 15 divided by 7, right? You go 2, 14, 1. How do you write that when you want to explain the answer? So if you want to write 15 over 7 and explain it, you say you start here on the top with 2, then you go 2 plus 1 over 7, right? So you say 2 plus 1 over 7, which of course you usually just write as 2 1/7, right? So we're going to do exactly the same thing here. So we're going to say that the result is the same loop. We'll start up here, then we'll say plus this number over that number. See? So for the result, we write y squared minus 4y plus 3. And starting here, we know that we have to say plus the remainder over the divisor. So plus 3 over y plus 2. Just as we did in the past with regular arithmetic and long division of just constants. Now we can check our answer as we did in the past in arithmetic using the division formula to make sure that this result satisfies the division formula, which says capital D, which is the dividend, or that which is being divided right here, is equal to the capital Q, which stands for the quotient right here, times the divisor, lowercase d, plus the remainder. So let's go ahead and multiply Q and D. So remember, this is Q, this right here is Q, and this is lowercase d, and of course this here is the dividend. So we want to know if quantity y squared minus 4y plus 3 times quantity y plus 2 plus r, or 3, is going to end up giving us the dividend. If it does, we've done it correctly. Okay, and so let's go ahead and do the multiplication. So we have, let's just use a table. So I'll just put the y plus 2 over here, and we'll put y squared minus 4y plus 3 horizontally. So let's go ahead and use the table method. So we know that y times y squared, that's y cubed, y times negative 4y, that's negative 4y squared. Y times positive 3, that'll give us plus 3y. Now moving to 2, 2 times y squared is positive 2y squared. 2 times negative 4y, that gives us negative 8y, and 2 times 3 will give us positive 6. We notice we have some like terms here. We also have some like terms here. Okay, so combining the like terms, we end up with y cubed minus 2y squared, because those two combine to give us negative 2y squared. Those two will give us negative 5y plus 6. And don't forget that we also have a plus 3 right there. So now we end up with y cubed minus 2y squared minus 5y plus 9, which is precisely what the dividend was. And now we have checked and we've done it correctly. So make sure you can handle a problem like this on your own, and then we'll move on to the next problem. All right, so in this one, notice that if we do a descending order check, they both pass. This one is going from a higher power to a lower power, so is this one. So they pass the descending order check. How about the missing powers check? Well, the divisor passes, right? There's no missing powers here. But the dividend is missing a term. So we're going to fix the dividend, okay? And to do that, of course, we need to bring in a filler. So we're going to write the dividend as u squared plus 0u minus 7, and the divisor is fine. We'll leave it as it is. All right, so let's go ahead and go through the procedure. We're going to divide. As always, pause and try it on your own. If you can, then come back. Trust me on this. Until you start doing that and you try to become more interactive as a learner, a great deal of progress won't be made. All right, so we're going to go ahead and assume you're back now. So we're going to go ahead and divide u squared by u. Remember, once put in descending order, you divide the highest degree term here by the highest degree term. Because you've put them in descending order, of course, that means the leftmost term here by the leftmost term here, right? So you get u squared divided by u is u. So we go ahead and write that here. Now you can see why we have the filler, right? Because otherwise we wouldn't have a place to put the u, right? So, but that's not the most important reason. You'll see in a minute in the next phase why it's important to have that. So now we go ahead and multiply u by u plus 3. So we get u squared plus 3u. We write that here. Notice if I didn't have the 0u, where would I put the plus 3u, right? It's much nicer if I have a place for it that I can put it on there. This is why we use fillers, okay? So now we subtract. Remember, top term minus bottom term, top term minus bottom term, etc. So the u squares, of course, not surprisingly cancel out, which they should if we've done it correctly. 0 minus 3. Let's focus on the coefficients. Of course, we know the u's are there, right? But what is 0 minus 3? Well, that's negative 3, right? So be very careful here. Negative 3u, and then bring down the minus 7. Of course, you can think of it as negative 7 minus 0, so it's negative 7 anyway, right? So now we repeat. What's the degree here? 1. What's the degree here? 1. That means we're not finished yet. We only stop when the degree here is strictly less than the degree here. So we divide negative 3u by u, and what do we get? We get negative 3. So we write the negative 3 up here, and we distribute. So we get So we want negative 3 times u plus 3, which is negative 3u minus 9. So we go ahead and write the negative 3u minus 9 here. And now we go ahead and subtract. So we get negative 3u minus negative 3u. Remember, that turns into a plus, so those cancel out anyway. And then, just so you can see, you have negative 7 minus negative 9. Again, that turns into a plus, so you get negative 7 plus 9, which is 2. That means this is our remainder. Why? Because the degree here now is 0, and the degree here is 1, so the degree here is strictly less than the degree here, so we stop. So now we write our answer. So we say u squared minus 7 over u plus 3 is equal to u minus 3. Remember the loop, start here, then say plus the remainder over the divisor. So plus, actually let's go back to blue. So plus 2 over u plus 3. And of course, to check it, we can see if the division formula is satisfied. So we're going to check to see if d equals dq plus r. So d here is u plus 3 and q is u minus 3 and plus the remainder, which is 2. Now, we know this is a product of two conjugates, so it becomes a difference of squares. So you get u squared minus 9 plus 2, which is of course equal to u squared minus 7, which is precisely what d is. So now I can just say d equals that without the question mark because I verified it, and now I'm done and it's fully checked. So there is an example with a missing term. Make sure you can handle that before we proceed. All right, so here we have another one with some missing terms. Go ahead and try this on your own and then come back. All right, so let's go ahead and do a descending order check. We notice that both the dividend and the divisor are in descending order. The dividend is going from a third degree term to a zero degree term, the divisor from a first degree to a 0 degree. So yes, they're both in descending order. How about missing powers? The divisor is okay, there are no missing powers, but notice the dividend actually has two missing powers. The square term is not there and the first degree term is not there. So the second and first degree terms are missing. So we're going to use fillers for those. So as far as missing powers, D is okay, but we need to fix the divisor. So we're going to write the divisor, I mean the dividend, apologies. So we're going to fix the dividend. We're going to write it as x cubed plus 0x squared, that's our filler for the second degree term, plus 0x, that's our filler for the first degree term, and then minus 27. And the divisor we just write as it is. So now the procedure is the same. Divide the first term by the first term. So we divide x cubed by x, we end up with x squared. So we write the x squared here and go ahead and multiply x squared by the divisor. So we get x cubed minus 3x squared, right? So we go ahead and write the x cubed minus 3x squared here. Now we go ahead and subtract. These of course cancel out. We have 0 minus negative 3. as far as the coefficients go. So let's focus on that. What's 0 minus -3? Notice that becomes plus, so it's actually +3. So we're going to have 3x squared here. We can bring down the rest, plus 0x minus 27. Now, we repeat the process, 3x squared divided by x. So remember, we always leftmost term divided by leftmost term. It's the highest degree term. Since we've put them in descending order, that's always going to be the leftmost term. So we divide 3x squared by x. We get 3x. So we write that up here. And we go ahead and multiply the 3x by the divisor. So we get 3x squared minus 9x. So we get 3x squared minus 9x. Notice how both of those fillers have helped us out. Otherwise, where would we have put the x squared, the -3x squared here, and where would we have put the -9x? So this is how the fillers help out. All right, now we go ahead and subtract. These cancel out. Once again, remember we have 0 minus -9, which is +9. So we get 9x. Bring down the -27. Now repeat the process. So we're going to divide 9x, because remember, we need to keep going because the degree here is 1 and the degree here is 1. We don't stop till the degree here is strictly less than the degree here. So we divide 9x by x, we get 9, and now we write the 9 up here, and we're going to multiply the 9 now by the divisor. So 9 times x minus 3 equals 9x minus 27. So again, this work that we're showing on the side, that's mostly for instructional reasons. When you get comfortable with these, you normally don't have to show all that, but if you're not comfortable with the material, definitely show it. So now we're going to go ahead and subtract, so these cancel out. Now, what is -27 minus -27? Well, that becomes a plus, right? So it's -27 plus 27, so it's 0. So this is a 0 remainder problem. So what does that mean? That means x minus 3 goes into x cubed minus 27 exactly that many times, right? So when we want to do the verification and we do d equals dq plus r, all we're going to check is the dq part, because remember, r is what? 0. So we just need to make sure d equals dq. So what is this is d, remember, this is q. So what is let's see if in fact d equals dq. So x minus 3 times x squared plus 3x plus 9, and it's plus 0, so we don't need to write that because the remainder is 0. So let's go ahead and multiply out x minus 3 by x squared plus 3x plus 9. If you've been watching the videos, you know that I'm a big fan of this table method. So we get x cubed, we multiply it out just like a times table. X cubed plus 3x squared plus 9x. And now we're going to distribute the -3 by those. So we get -3x squared minus 9x minus 27. Now, if you notice, these two are like terms, and when you combine them, they cancel out. So those are gone. And the same with, let me use a different color. So these cancel out. Notice that these two, 9x and negative 9x, are also like terms. They can be combined and they cancel out, again leaving 0. So notice all you're left is x cubed with is x cubed minus 27. So, and that is exactly D. Remember, this right here is what we call capital D, or the dividend. So the dividend is indeed the divisor times the quotient. So you notice when we multiply x minus 3 by x squared plus 3x plus 9, we got exactly x cubed minus 27. So we're done. We've done the verification and it's done correctly. All right, so that was an example with two missing terms or powers. All right, let's go ahead and take a look at this one. Notice that this one has some missing terms. So go ahead and try it on your own and then come back, see if our answers agree. Don't forget to do the 2 checks. Okay, so as far as descending order check, we notice that they both pass. As far as missing powers check, we need to fix both D and lowercase d, so the dividend and the divisor. So we notice that the dividend is missing m cubed term and m term. So we're going to write it as m to the 4 plus 0m cubed minus m squared plus 0m minus 2, and we're going to divide that by the divisor, which we will fix by adding a 0m. So m squared plus 0m minus 2. Then we proceed as before. We divide the highest degree term by the highest degree term, m to the 4 divided by m squared. I think I'm going to skip showing the side work now. I think you should be okay by now. So we get m squared. Now we go ahead and multiply m squared by all of that. So we get m to the 4. What is 1m squared times 0m? That's going to give me plus 0m cubed. And then minus 2m squared. So we go ahead and subtract. Those cancel out. 0 minus 0 is of course 0, so these are gone too. Negative m squared. So what is negative? Let's look at the coefficients. What's negative 1 minus negative 2? Well, that's going to become a plus. So it's negative 1 plus 2, so it's 1, right? So we get m squared. Bring down the plus 0m minus 2. Now go ahead and divide m squared by m squared. So you get a plus 1. And we go ahead and multiply the 1 by all of that. And of course, that won't change anything. We just get m squared plus 0m minus 2. Cancels, cancels. And of course, negative 2 minus negative 2 is negative 2 plus 2, which is also 0. So the remainder is 0, which means m squared minus 2 goes into m to the 4 minus m squared minus 2, exactly m squared plus 1 times. Now notice here, the fillers didn't do us a lot of good. Now there was a reason for that. The reason is that we had only even powers in both of these. When that's the case, sometimes you can get away without doing the fillers, but notice the fillers didn't hurt either. So it's usually safer to go ahead and bring in the fillers, even though sometimes they may not really be needed. All right, so that's that. And we're just going to look at one more scenario before we call it the day. All right, this is a problem that looks a little bit scarier compared to the rest of them just because of the fractions, but it really isn't, because if you handle it cleverly, you won't need to deal with those fractions at all. So here's the way we're going to handle it. Let's go ahead and write it as a quotient. So we have 1/3 x squared plus 4/3 x plus 1 divided by 1/3 x plus 1/3. So Notice that it's okay to multiply the numerator and denominator of a fraction by the same number, right? So if we pick that number cleverly, we'll go ahead and clear all the fractions. So we look at all the denominators. They happen to all be 3's. If they're not, no big deal. Just find the LCD. And we notice that the LCD is 3. So we go ahead and multiply the top and the bottom by 3. And of course, remember, we're going to be distributing, right? So why don't we just write the 3 next to each term? Go ahead and distribute right away. And we're going to do the same on the bottom, of course. If you do something to a numerator of a fraction, you have to do the same to the denominator. So because then you'll just be multiplying by 3 over 3, which is 1, which doesn't change anything, but it just changes the way it looks in a very useful manner. So we're going to distribute here too. Now watch. What's left? This 3 will cancel that. This will cancel that. Here nothing cancels. Here those cancel, and here these cancel. So now let's see what's left. What's left is x squared plus 4x plus 3 divided by x plus 1. Does that look familiar? Let's pause and back up for a second. Do you remember it now? It's the very first example that we did. So even though it looks so different, right? So of course we're not going to redo something we've already done. So by the way, they did both pass the descending order check and the missing powers check, didn't they? They do. So just the whole point of this problem was, if you get fractions, there's no need to deal with them. Get rid of the fractions by finding the LCD of all the denominators that you see, okay? And then multiplying that number on the top and the bottom, and that'll clear all the fractions. And that way you can just do a much simpler problem, and that should do it for dividing polynomials by polynomials. All right, so make sure you practice these and stay safe until our next video.